is everybody today? Let's see, we still need Olivia and Hunter. Hello, hello. And then here comes Hunter. All righty, how is everybody today? Everybody have a good weekend? Anything great and exciting or anything horrible and terrible? Just a weekend? Okay. What I'll do is I'll go ahead and pull up my screen real quick. Okay, so let's see. Homework. Was it just page 66 on the homework?
Yeah, it was.
Okay. I just want to make sure I didn't miss something. I only have these two lessons stuck together in here. So let's see. So we've got page 66. We'll go ahead and look at those. Excuse me. Let's see. We got the teacher book. And that is from lesson 30. Alrighty, so lesson 30, page 66, activities 4. All right, I will read out the answers and then you guys can let me know if you have any questions. So I'll go ahead and do the answers for activities 4. The first one is 19, then I have 3, 26, 37, 4, 18, 1, and 5. Any of those that you missed and you want me to go through them? Okay, so make sure that if you are missing them though, you mark them so you can go back and make corrections just in case, okay? Let's look at activities 5. We were dealing with inequalities. The first one is x is less than -2. The middle one is x is greater than 1. And the last one, x is less than 2. Any questions on any of those? Very good. And then activity 6, we crossed out the middle column, so we just have the left and right. So on the left-hand side, I have 5.41. Underneath that is 8.913. Then I have 0.07745. And then the last one in that column is 0.000149. Any questions in that column? Okay, right-hand column. The first one is 0.463. Underneath that, 0.095. Underneath that, 0.0169. Then the last one in that column is 0.00075. Any questions on that column? All right, now we'll do the division problems. We'll go across the top and then bottom. Okay, so we'll do the 3 on top, then the 3 on the bottom. So the first one is decimal 17. The next one is 90. And the third one on top is decimal 015. On the bottom row, the first one is 1,100. The next one is decimal 17. And then the third one was 130. Any questions on those? Awesome. All righty. So we are going to be moving right along. So that was, we've dealt with our metric systems, dealing with kilo, and then we did centi and milli. All right, so today we are going to be starting with a new section dealing with fractions. So this is going to start on lesson 32. All righty. So lesson 32, equivalent fractions. Hang on just a second and I'll get these loaded up real quick. I thought I had. Go ahead and get the whole section copied, and that way I don't have to worry about doing this again. So basically, we're getting ready to start our whole unit about fractions. And so who knows what the top part of my fraction is called? Does anybody remember what we call the top part of my fraction?
Numerators.
The numerator, good. And what is the bottom part called?
Denominator.
Denominator, good. So we have the numerator and the denominator, okay? And so one of the things that I always have to make sure of when I'm dealing with fractions is that anytime I have an answer, I want to make sure that it is in simplest form. And when I talk about simplest form, that means I can reduce it. And the way I reduce it is through the process of division, okay? When I look at what is in the numerator and what is in the denominator, I look to see what number can divide evenly into both the numerator and the denominator to be able to simplify it, okay? And so let's see real quick. So this whole unit, okay, starts on 32 and goes through 42. Okay, so let's get ready and pull that up. I can get it to load. There it is. Okay. Okay. So like I said, we've got, we talk about fractions. We have the numerator and the denominator. We can simplify by dividing my numerator and denominator by the same term. And one of the things that when I'm teaching fractions, I always kind of describe the numerator and denominator as kind of like brother and sister or just siblings. So if you have a sibling, you know that if mama gives something to one, that the other one wants it too. If mama were to come out and say, hey, I'm giving you $5, your sibling is going to want $5 too. Or likewise, if mom came home and gave your sibling $5, you're going to want it as well. So I kind of treat fractions like that. Whatever is done to the numerator has to be done to the denominator. Okay, I can't just change one of those without changing the other as well. And so also, one of the things I want you to kind of start thinking about also is, and we'll talk about this more later, but basically a fraction is an example of a division problem. So that fraction bar means the same thing as division, okay? So like if I were looking at, first of all, we'll just go ahead and look at our 1/2 right here. If I'm looking at 1, that's basically 1 divided by 2. All right, and usually the top number is going to be smaller than the bottom number. If it is not, that's called an improper fraction. Improper fractions where I have the larger numbers in the numerator and a smaller in the denominator. We're going to be working with those in a little while. But basically, usually the smaller number is in the top. And when the smaller number is in the top, then that represents that I'm dealing with a number that is less than 1. Okay, it means that it's a number that is going to be a decimal if I were to divide it. So like if I had a calculator and I divided 1 divided by 2, it's going to give me a decimal answer of 0.5. Okay, so on this section, we're going to be talking about equivalent fractions. And I can find equivalent fractions by multiplying the numerator and denominator by the same number. So it says equivalent fractions are fractions that have different numerators and denominators but are equal in value. For example, 1/2 and 2/4 are equivalent fractions because they both indicate equal amounts of something. When an object is divided into 2 equal parts and 1 part is chosen, that is the same amount as if the object were divided into 4 equal parts and 2 parts were chosen. To find equivalent fractions, multiply both the numerator and denominator of one fraction by the same number to get the numerator and denominator of the equivalent fraction. For example, given the fraction 2/3, find an equivalent fraction by multiplying the 2 and the 3 by the same number to get a new fraction term. So what they did here is they said, okay, I started off with 2/3. Okay, so 2/3 was the original fraction. Now I am multiplying my numerator by 2 and my denominator by 2, and 2 times 2 is 4, and 3 times 2 is 6. So 2/3 is equal to 4/6. These are equivalent fractions. They would represent the same amount. So basically kind of a visual we can look at. Let's say that I had something like this, okay? And I was going to, my top one, let's say it was broken into thirds, okay? And 2 of the thirds were shaded, all right? But then my bottom one is broken into sixths, okay? And so 4 of my sixths are shaded. You can see how those are equivalent because you can see that this would represent 2/3, but it's the same exact amount that would be shaded. Okay, so that's what equivalent fractions mean. That if I just broke it into that many parts, the number of parts is in my denominator and the number of shaded is my numerator. Okay, so let's look at the first one. I have 1/2. What I'm looking at is I started with 2 and I got to 4. So what do I multiply 2 by to get to 4? I just multiply by 2, right? So if I multiply my denominator by 2, I have to multiply my numerator by 2. So 1 times 2 is 2. So 1/2 is equal to 2/4. The next one, 1/3 is equal to something over 6. Again, I say, what do I multiply 3 by to get to 6? And again, I'm multiplying by 2. But what I multiply the denominator by, I have to multiply my numerator by, and 1 times 2 is 2. So 1/3 is equal to 2/6. All right, now I have 2/3 is equal to something over 9. I have a 3 in my denominator, and then it's going to multiply to equal 9. So that means I've multiplied by 3. If I've multiplied the denominator, I have to multiply the numerator, and 2 times 3 is 6. And then the last one, 3/5 to something over 15. Again, if I start with a 5 to get to 15, I multiply by 3. So I have to multiply my numerator by 3, and 3 times 3 is 9. Any questions about that? Probably this is just a review, something that you've done before. So let's go ahead, and I want you to work on activities 2. Look at what you started with in the denominator, look to see what the new number is, and find your new numerator. Okay, go ahead and work on that right now. If you have questions, though, let me know. All right, so go ahead and take a look at these. And if you notice that the last column, they left the first one blank. So if we were multiplying by 2 to get my second equivalent fraction, what did you have to do to get the first one, what you started with? You had to divide. Good. So if you look at the first one, something over 4 equals 9 over 12. Well, to get from 4 to 12, I had to multiply by 3. So that means I'm going to have to divide by 3 to get my numerator. So you end up with 3/4. So I've got the answers if you want to look up and check yours. And if you have any questions on something, let me know. Were there any of these that you had trouble with? Any questions? Okay, good. So like I said, you're mainly just seeing what did you multiply the first denominator by to get the second denominator. Then you have to do the same thing to the numerator. The last column, you had to look to see what you multiplied by, because then that's what you needed to divide by to get the first numerator. All righty, so we're going to go ahead and turn the page to page 72. All right, so on 72, on this page, let's go through activities 3 together. Okay, let's look at activities 3. Let's go ahead and review our use of signs. So when I'm adding and I have the same sign, my sign will stay the same, and I add my two numbers. So 34 plus 86. So I know that I've got 4 plus 6 is 10, carry my 1, and 3 plus 8 is 11, plus 1 is 12. But now the one below that, I have a positive plus a negative. Remember, if my signs are opposites, I keep the sign of the larger number, which is negative, and then I have to find the difference of the numbers. So now I've got to do 86 minus 34. So I know I'm going to have a negative answer, and 6 minus 4 is 2, and 8 minus 3 is 5, so negative 52. Again, the one below that, I've got opposite signs. So I keep the sign of the larger. This time, the plus is with the 86. And again, I'm going to find the difference, but this time it is positive. Now the next one, my signs are the same. So I keep my sign, but I add them together and get 120. Okay, same signs, keep the sign, add them together. Opposite signs, keep the sign of the larger and find the difference. Let's look at the next side. Same thing here, except for I'm subtracting. Okay, remember that when I'm subtracting, I want to change to addition, but I have to take the opposite sign of whatever follows my change in signs. So here, if I have positive 169 and I want to change this to addition, that means this has to become negative 498. So I change from subtraction to addition, and my positive 498 becomes negative 498. So now I'm going to use my rules for addition. I've got opposite signs now, so I keep the sign of the larger and find the difference. So let's see, 498 minus 169. So I've got negative 329. Again with the negative, the next one, change from subtraction to addition, but now I have to change my negative sign to a positive. So now I'm adding, and my signs are the same. So a positive plus a positive is a positive. And now I'm going to add 169 and 498. And 169 plus 498 is 667. On my next one, I want to change to addition. Take the opposite sign. Now I have a negative plus a negative. That's going to give me a negative. I keep my sign, add them together. The last one, change from a negative to a positive. That means my next one becomes positive. Keep the sign of the larger, find the difference. So it's going to be positive 329. Does everybody remember rules for addition and subtraction with negatives and positives? Very good. All righty. We are going to skip over activities 4, and our first part of homework will be activities 5. Okay. Before we end class today, we'll be doing a review because we will have an assessment on our decimals. Okay. It will be adding, subtracting, multiplying, and dividing decimals, as well as using our powers of 10 to move our decimals, either to make it a greater number or a smaller number, and we'll be talking about that though. The test will go home on Thursday, so you'll have over fall break to work on it. Okay, so we'll do our review today. We'll write out a study guide to have, and then it'll go home on Thursday, and it won't be due until the Monday we get back from spring break. From fall break. I keep calling it spring break, but fall break. Okay. All right. So this will be a little bit of practice to help us get ready for that test. And we will go ahead and move on to lesson 33, fraction decimal conversion. Okay. So like I said earlier, to convert a fraction to a decimal, you divide the numerator by the denominator. So remember I said that this division bar, our fraction bar, is the same as a division sign. But the main thing to remember is that whatever is in the numerator is what is written first in the division problem. Okay? So when I have 1 in my numerator, that means 1 divided by 2. Now, remember that if I do 1 divided by 2, and I'm going to divide, that means my 1 is on the outside. Sorry, I put that in the wrong place. My 2 is on the outside and 1 is on the inside. Remember when we were working with dividing with decimals, if I don't have something, I can add a decimal and a 0. So that means my decimal is going to go up there in my answer. And so now this is not 2 into 1, it's 2 into 10. And that'll go 5 times, and 5 times 2 is 10, and I subtract and there's no remainder. So I can see that 1 divided by 2 is decimal 5. Okay? So that one was an example of a terminating decimal. That means that it does not keep going, it just ends. When I have no remainder left, that's a terminating decimal. Now notice in the next section it says if a fraction results in a repeating decimal, you're going to put a bar above the digit or digits that repeat to indicate a repeating decimal. So when I have 1 divided by 3, or 1/3, okay, let's look at that one. If I were to divide, let me make it a little bit smaller. Actually, let's see. If I did 3 into 1, again, I would put my decimal, add a 0. I know 3 will go into 10 3 times, and 3 times 3 is 9. I subtract, and I've got a 1. Add a 0, bring it down, and look, I'm dividing 3 into 10 again. And I could keep on going and going and going, and it's never going to end. It's just going to keep on repeating, okay? So when I have a digit that repeats, it's a repeating decimal, that is why my line only goes over 1/3, because it's the 3 that continues repeating, okay? So it says, for example, 1/3 is equal to 0.3 repeating. Then it says to convert a decimal to a fraction, write the numeric portion on the right side of the decimal point as the numerator and the place value of the digit on the right as the denominator. So basically, to go from a decimal to a fraction. Remember how we talked about our place value, and this tells me tenths place. Okay, one digit after the decimal is my tenths place. So I use this as my numerator, and then because it's in the tenths place, 10 becomes my denominator. So 0.3 is equal to 3/10. Now, one of the things I always have to be careful of when I'm writing fractions is that I have to reduce to simplest form anytime I can. Okay? So now I reduce the resulting fraction if possible. So like in this example, I've got 0.5. Again, this is in the tenths place. So my denominator is 10. My numerator is 5. Now I've got 5/10. I need to make sure that I have it in simplest form, but when I have a 5 and a 10, I know they're both divisible by 5. So you can see that they divided the numerator and the denominator by 5. So I ended up with 1/2 in simplest form. So I always want to check and make sure I have simplest form. Okay? So now what I need to do is we're going to look at the classwork over here. And actually you can see down here in the yellow, in your book it's yellow, you can see that we've got, these are fraction decimal equivalents. And the sooner you memorize these, the easier it's going to be on you. Okay? These are just common fractions that you may deal with in decimal form. Now there's a few of these that you might not see quite as much, just like, but I'll put a check mark by the ones that you're going to see pretty often. 1/2 and 0.5, 1/3 and 0.3 repeating, 2/3 and 0.6 repeating, 1/4 and 0.25, 3/4 is 0.75. And I told you guys that when I'm dealing with fourths, I use that to think of quarters. So 1/4 is 0.25, 2/4 would be 0.5, but that would reduce to 1/2. 3/4 is 0.75. 2/5 you'll see some. 1/8, 3/8, 5/8. And obviously our tenths are going to be the easiest ones to convert. But, you know, definitely the ones on the left-hand column are ones that you just want to know. You want to know that 1/4 is equal to decimal 25. You want to know that 2/3 is 0.6 repeating. Okay, these are going to be fractions and decimals because there's going to be times when you have something in decimal form and you need to express it as a fraction. Okay, and it'll just be easier if you memorize them. But what we're going to do is we are going to look at these, converting each fraction to a decimal. Okay, so remember, to convert a fraction to a decimal, I'm going to start and say 4 into 1. I divide the denominator into the numerator. I know that 4 will not go into 1, so I put my decimal. So 4 will go into 10 2 times, and 2 times 4 is 8. So 10 minus 8 is 2. Add a 0, bring it down. So now I have 20. And 4 will go into 20 5 times. 5 times 4 is 20. So I have no remainder. Okay. Below that, I have 2 divided by 5. So that means I have 5 into 2. 5 will not go into 2, so I put my decimal and add a 0. Go ahead and put my decimal in my answer. And I can see that 5 will go into 20 4 times. And 4 times 5 is 20. I subtract, and I have no remainder. So 2/5 is equal to decimal 4. Go to the right-hand side. 3 divided by 8 is what 3/8 means. So I have 8 into 3. 8 won't go into 3, so I add my decimal and a 0. Put my decimal in my answer. 8 will go into 30 3 times, and 8 times 3 is 24. I'm going to subtract. 30 minus 24 is 6. Add a 0, bring it down. 8 will go into 60. I've got to think about my multiples of 8. I know it's going to be less than 10 because 8 times 10 is 80. And then so a lot of times when I'm thinking through these things, like I know 8 times 10 is 80 and 8 times 5 is 40. So I know my answer is going to be somewhere between 5 and 10. So I'm going to start counting up. So 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. And 8 times 8 is 64. So I know that it's going to be 8 times 7. 7 times 8 is 56. And I'm going to subtract. 60 minus 56 is 4. Add a 0. Bring it down. 8 will go into 40 5 times, and 8 times 5 is 40. So I finally get finished, and 3/8 is equal to decimal 375, or that would be read as 375 thousandths. Remember, I look at what my furthest out place value is from the decimal. My 5 is in the thousandths place, so I have 375 thousandths. And finally, 2/3. 3 will go into 2. It won't go into 2, so I add my decimal and 0, put my decimal in my answer. And 3 will go into 20. 6 times 3 is 18. Subtract. 20 minus 18 is 2. Add a 0, bring it down. 3 will go into 20. 6 times 3 is 18. At this point, you should see that we've got a pattern going on here. So I would just write that as decimal 6 repeating. Any questions about those? Just remember, I can divide my numerator by my denominator. All righty. So now it says convert each decimal to a fraction. All right. So the first thing I'm going to do is start with my 0.7, and I've got to look at that one and think about what is my place value of the digit after the decimal, and that's my tenths place. So that means I'm going to put a 7 in my numerator, a 10 in my denominator, and then I want to see if I can reduce it. And I can't. 7 is a prime factor, so there's nothing I can divide into 7 and 10. Look at the one next to it again. I have a decimal 4, so my 4 is in my numerator, 10 is in my denominator, but these are not simplified. What will divide evenly into both 4 and 10? 2. So 4 divided by 2, 10 divided by 2. 4 divided by 2 is 2, 10 divided by 2 is 5. So 2/5. All right, decimal 2. 2 goes in my numerator, 10 is in my denominator. Again, I can simplify both of them by dividing by 2, divided by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. All righty, now we've got decimal 8/3 repeating, okay? So this one is not as easy just to be able to say what it is, because I know that I've got that repeating decimal. So I can't just say it's 0.83 over, whoop, not 0.83. I can't say it's just 83 over 100 because of that repeating decimal. Okay, so a lot of times it's much easier to go ahead and memorize these, but I want us to go ahead. They don't give us many repeating decimals here. I think what I'll do is I'm going to go ahead and show you how you calculate a repeating decimal, but they don't really give you many of them, so I'm not going to make you learn the process. It's just going to help you if you memorize these repeating decimals on the yellow page, okay? So I think for most of your homework and practices and everything, you're just going to need to know the repeating decimals that are in yellow. But I will show you why, okay? I'm going to show you how they get what they get. So you can see in the yellow that it says that 0.83 repeating is equal to 5/6. Okay, so that's what they've told us in the yellow. The way that I end up calculating a repeating decimal is I go ahead and set x equal to my repeating decimal. So I've got my repeating decimal there, okay? Now, if I were going to clear this decimal, I would have to multiply it by 100. So that means I would have to multiply that side by 100 and that side by 100. So now I've got 100x is equal to 83.33. Now, since x is equal to 0.83, I would subtract those. And when I subtract 100x minus x is 99x, which equals, if I were to subtract, if these were my repeating numbers, 83.33 repeating minus 0.83. My 3 repeating cancels out. So a repeating 3 minus a repeating 3 is 0. So then I'm just going to subtract as usual. And I end up with 82.5. Let me write that a little bit better. Okay, so basically I set my equation, or I set x equal to what my repeating decimal is. I know to clear that decimal, I would multiply by 100 because it's 2 places after the decimal. So then I multiply that by 100x, by 100. So then I subtract the 1x that I had, and then I would divide by 99 and divide by 99. So then 82.5 divided by 99 ends up equaling, just a minute, I'll tell you. 82.5 divided by 99 the first thing I would have to do, actually I don't put it in as a decimal like that, I would go ahead and have it as 82.5 over 99 because I'm trying to make it a fraction. I've got to clear that decimal as that 82.5, so that means I've got to multiply my numerator and denominator by 10. 825 over 990. Now I can start reducing, and I can divide both of them by 15. And so 825 divided by 15. Actually, I can go more than that. So let me 825 over 990 divide by 5 because those are the first things we see. Okay, so that would give us 165 over 98. I'm sorry, 198. Divide by 3 gives me 55 over 66, which I can see now I can divide by 11, which gives me 5 over 6. Doesn't that look like fun? No. So that's why I'm not gonna make you learn how to do this process. I just wanted you to see that there is a way to show that a repeating decimal equals a fraction. And if I worked out the problem 5 divided by 6, I'm going to end up with 0.83 repeating, like we've already seen. But I wanted you to see that there is a process to get there. You're not going to have to learn that process. If you just memorize the repeating decimals in the yellow box, you'll be fine for this section, okay? All righty. So now what we're going to do is we are going to go ahead and look at activities 2. Use the yellow box to write the decimals for activity 2. Go ahead and do that now. And then we only have a couple of minutes till break time. All right, so going down from top to bottom on the left, you've got 0.5, 0.3 repeating, 0.25. Then you have 0.2, 0.016 with just the 6 repeating, then 0.125. Oh, did I write the same thing? And then for 2/3, I'm sorry, is just 0.6 repeating. So just the 6 repeats on 2/3. Notice that on 1/6, it's just the 6 repeating, not the whole entire 1/6. Okay. 2/5 is equal to 0.4. 3/4 is equal to 0.75. 3/5 is equal to 0.6. 3/8 is equal to 0.375. 5/6, like we looked at, is equal to 0.83 repeating. 5/8 is equal to 0.625, and 7/8 is equal to 0.875. All right, go ahead and take a break.
Miss Jennifer, you're on mute.
Just sitting over here talking to myself. Thank you. Okay, so what I was saying is we went through, let me go back to that homework to make sure that y'all know what to do. So what we will do is we just went through the converting decimals to fractions and fractions to decimals. We've got our chart that we can look back to. Remember, I told you it's going to be to your benefit to memorize as many of these as you can. So for the homework in activities 3, you can look back at the chart to get these answers. So we have activities 3, and then activity 6 will also help us prepare for the quiz. Okay, so we can see that our homework, we said, would be activities 5. And then, whoops, I went too far. Activities 5 on page 72, and then activities 3 and activities 6 on page 74. Okay. Help me remember, did y'all get a decimal packet? Yeah.
I mean, we got the packet that we got on Monday, and then we also have that for homework due on Thursday. But
Okay.
I don't know what that's what you're talking.
So let's go ahead and take a look at that packet for just a minute. Okay. Let me pull it up real quick. Where is it? This is it. Nope. I don't know if I had loaded it on here yet. Let me pull it out of my email real quick. Let's see. So this would have been, I didn't think it went back that far. Because I passed it out in class, right?
Yes, ma'am.
Okay, I guess I don't have it in my email since I didn't email it to y'all. So let me go grab mine real quick. Hang on just a sec. Well, I don't know. I've got a few stacks of papers around here, and I'm not sure which stack I stuck it in. So I may just have to pull it up on my computer real quick and save time. All right, so let's see. I'm going to pull it up on my computer.
Emailed it to me.
I had emailed it to you, hadn't I? So it should be in my email. I'm glad you said that. Let's see. Let's go back to my sent mail. So I sent it. Come on. Here it is. Decimal packet. Thank you. I think I was looking for it to say like unit 3 or something instead of just decimal packet. All right, so let's do this again. Okay, so this is what's counting as our quiz in this section. And if you are ready to go ahead and turn it in, I will put a place in the, I'll go ahead and put a place in our homework upload place to go ahead and turn it in. If you want to wait until Thursday, you can finish it up and turn it in on Thursday. Okay, but like I said, this is what's going to count as our final quiz. So the first thing, addition and subtraction of decimals. Okay, the good news is they went ahead and lined it up for us. Okay, so all you have to do is do the calculation. Now, the main thing to remember with addition and subtraction of decimals is that if I do not have a number in a place value location, I need to put a placeholder number. And what placeholder number can I plug in? What is the placeholder number that I put in for missing values? A 0. Okay. So realistically, when I'm adding, it's not as big of a deal. Okay, because I put in a 0 there and I'm still going to have 7, right? The plate, and then like even below it, I could put a 0 in, a placeholder 0, and I'm just going to get 1. The place that really makes a difference is when I am subtracting. And it's not when I'm subtracting and I'm missing a place in my second number. It's going to be when my top number is missing places. Okay, so make sure you go back through your subtraction and check to make sure that you put your placeholder values. Okay, because remember, this 0 would become a 10, which would make this one become a 9 and this one become a 9, and that 2 would have to become a 1. Again, I'd have to go ahead and make that 1 an 11, simplify this by reducing it to a 4, but now I'm going to have to make it 14 by reducing that to a 7. So we've got a lot of borrowing going on here, and if I don't have my placeholder zeros, I might forget to borrow. Okay, because remember, I'm saying 3 subtracted from the top number, and 0 minus 3 is not 0. Okay, so I have to be real careful, and 0 minus 3 is not 3. 0 minus 3 would be a -3, but we're not dealing with positives and negatives right now, so I've got to make sure I've got my placeholder zeros. Okay, so on addition and subtraction, they're already lined up for us. You don't have to reline them up. They're all your decimal places and place value are right, but make sure you've got your placeholder zeros there. Okay, now our inequalities. Okay, our inequalities, basically we solve exactly the same as we do in equality, but if I multiply or divide by a negative number, I have to flip my sign. So go back through and make sure you have done that. Okay. Activities 2, addition, subtraction, multiplication, and division. When I multiply, I need to make sure that I put my decimal in my answer. I do not worry about it as I'm multiplying. I just go ahead and multiply like usual. then I look to see how many decimal places I have in my problem. And then that's going to be how I decide where my answer goes. So in this one, I would just multiply 2 times 7 is 14, carry my 1. 9 times 7, 63, plus 1 is 64. Then I can see I've got 1 decimal place in my problem. So that means I start at the right-hand side, move 1 place to the left, and that's where I would put my decimal for my answer. Okay? So count the number of places in your problem, start at the end of your answer or the end of your product, move that many places to the left, and that's where your decimal point goes. Dividing. Remember that when I'm dividing, I can only divide by whole numbers. So 0.6, my decimal has to move 1 place to the right to be able to divide. So if I move that decimal 1 place to the right, I have to move the decimal in my problem 1 place to the right. I go ahead and put it in my answer and then divide. Okay, so move my decimals, but if I move my divisor, I have to move the dividend as well. Any questions on adding, subtracting, multiplying, or dividing decimals? All right, then we had our powers of 10. And remember we said when we have a positive exponent, my number gets bigger. A negative exponent means it's getting smaller, so my decimal moves to the left. So when my exponent is 5, that means my decimal is going to move 5 places to the right, or I'm going to have 5 zeros. When it's a negative 5, I move it 5 places to the left. Multiplying powers of 10, I add the exponents. Dividing powers of 10, I subtract my exponents. And then remember, when I use my exponent to determine moving my decimal, so here I've got 0.7 times 10 to the first. That means I would move it 1 place to the right. 0.35 times 10 to the second, move it 2 places to the right. 8.14 times 10 to the third, move it 1, 2, 3 places to the right. If I have to put a placeholder 0, whoop, I didn't mean to do that. 8, 1, 4, 0. Anything to the 0 power equals what? Just 1, right? Anything to the 0 power is 1, so 9 times 10 to the 0 power is just going to be 9 because that's the same as 9 times 1. All right, so positive exponents, you're moving your decimals to the right. Negative exponents, you're moving your decimals to the left. So like if I have 13 times 10 to the negative first, right now in 13, my decimal is right here at the end of it. So if it's 10 to the negative first, I have to move my decimal 1 place to the left. So that becomes 1.3. Did we already talk about what numbers to do on each of these? Yeah, let's go ahead and review those real quick. All right, so on page 1, remind me what we're doing on page 1.
On section 1, we're doing the first 9, or we're doing 3 on each line.
3 on each row. That's right. Did we draw our line like that on this page?
Yeah.
Okay, so good. I was thinking that was right, but I didn't want to. Okay, so we drew our line like that on the first page. So you only have to do the first 9 of addition, the first 9 of subtraction. The others are bonus. Okay. What about on page 2? What did we end up doing? Didn't we divide it kind of the same way like that? Okay, so we knocked off the top 2 in the inequalities. So we just had 4 on the inequalities. And then we did the first 4 in each line of addition, subtraction, multiplication, and division. Then the rest of them are bonus. And then what about the next page?
All of that is homework.
All. Okay. I was thinking that was all. And then we only did half of this page on the last page? Did we draw it in half
Yes,
again?
ma'am.
Okay, and we said the
Yes,
left half, the left side is homework and the right
It's
side's
homework.
bonus?
Yes, ma'am.
Okay, so homework and
On
bonus.
that page for
Uh-huh.
on the page with the operations with powers of 10, I only have like half the page printed. Like I only have I only have like that. I don't know if you can see that, but there's not the other half.
Oh, okay. So what I'll do is I'll just go ahead and email you this packet. And then that way, on this one. Yeah, that's all that there is. That's on, let me number these real quick. So this is page 1. Oh, come on. Then page 2. Page 3. Is that the one where it says worksheet 15, Olivia? So that is all that's on page 3. And then page 4 is the one that we split in half too. All right, so again, the homework portions are what will count as a quiz grade, and then the other portions are bonus. Okay, so we've got bonus on each page that you can do, except for page 3 is all, okay? But what we'll do is if you want to, so like I said, our homework will be to finish up our packet. If you get it finished earlier than Thursday and you want to upload it and go ahead and get it to me, that's great. Let me go ahead and add that to, real quick, I'll go ahead and add that to our assignment page. Let's see, PreAlgebra. Go to our class home page, and I'm going to add an assignment. And so this will be our decimal packet. And it's going to go as a test grade out of 100 points. And I'll put that it's due on Thursday, which is the 8th. If you get it to me beforehand, that is great. Okay, so that has been added, so you have a place to upload it whenever you're ready to. And any questions about that or the homework that we have tonight, or the homework that we talked about with fractions? Okay, so it's 2 o'clock. We're done with what I had planned for today. So you can stay and work on finishing your packet, work on the fraction assignment, work on whatever you want to, and I'm here to help you. If you're done with everything and you're ready to sign off, you're welcome to sign off. But if not, I'm right here so you can hang around and get some work done.
So all the homework we need to do is on the website, where it's listed on the website.
So it hasn't, no, what I did is I just went ahead and put in a place to upload your packet.
Okay, so can you remind me of the homework again?
Yeah, absolutely, absolutely. So we have page 72, activities 5. And then we have page 74, activities 3 and 6.
Okay.
And I'll also get ready and start uploading all the dates and assignments and things for our upcoming assignments. Okay.
Okay, thank you.
You're welcome. And just if you have questions, go ahead and unmute and ask your questions as you're working.
I'm done.
You're all done? Awesome. Well, very good. Any questions before you go?
I don't think so.
Okay. Well, very good. Well, if you come up with any, just let me know. And if not, I will see you Thursday.
Okay.
Okay. Bye, Hunter.